Good morning, Valenzuela Senior High School learners. I'm Miss Lorena Ral, your Valenzuela FB live streaming teacher for this week. Welcome to our new episode in Physical Science. We are now in week 3 and we will learn all about the intermolecular forces. For today's most essential learning competencies, number 1, describe the general types of intermolecular forces. And number 2, explain the effect of intermolecular forces on the properties of substances. But before we start, let us have a short game. It is entitled 4 Pigs 1 Word. What you will do is to simply guess the positive picture and write in the comment box your answer. I'm only giving you 5 seconds to answer it. So, are you ready, guys? Let's the game begin. For the first word, it is composed of 5 letters. Let us see the first clue picture. The second one, the third one, and the fourth one. So, keyboard warriors, you have 5 seconds to answer. Timer starts now.
5, 4, 3, 2, 1.
Time's up. If you answered force, and that is the correct answer. Okay, so let's see the second word. For the second word, it is composed of 3 letters. And let us see again the first clue picture. The second one, the third one, and the last clue picture. Okay, so keyboard warriors, you have 5 seconds to answer. Timer starts now.
5, 4, 3, 2, 1.
Okay, time's up. If your answer is ion, and that is the correct answer. And let's see for the third word, it is composed of 6 letters. So let us see the first clue picture. The second one, the third one, and the last clue picture. Okay? Again, keyboard warriors, you have 5 seconds to answer. Timer starts now.
5, 4, 3, 2, 1.
Okay, time's up. If you answered dipole, you got it right. And let us see the last word. It is composed of 6 letters. So let us see the first clue picture. The second one, the third one, and the last clue picture. Again, keyboard warriors, you have 5 seconds. Timer starts now.
5, 4, 3, 2, 1.
Okay, if you answered London, you got it right. Okay, so based on the game we have played, we found different words such as force, ion, dipole, and London. All the words were connected to intermolecular forces. So, join me and we will define, visualize, and compare all these forces and explore the wonders of intermolecular forces in our lives. So there are 2 kinds of forces or attractions that operate in a molecule, intramolecular and intermolecular. To start, let's define intramolecular and intermolecular. Intra means within. So intramolecular forces are the forces that hold atoms together within a molecule. Inter means between. So intermolecular forces are forces that exist between molecules. So that's the difference between intramolecular and intermolecular forces. Intermolecular forces are forces between molecules. Depending on its strength, intermolecular forces cause the forming of 3 physical states: solid, liquid, and gas. The physical properties of melting point, boiling point, vapor pressure, evaporation, viscosity, surface tension, and solubility are related to the strength of attractive forces between molecules. These attractive forces are called intermolecular forces. The forces are named for the Dutch physicist Jan Dietrich van der Waals, who in 1873 first postulated these intermolecular forces in developing a theory to account for the properties of real gases. Solids that are held together by van der Waals forces characteristically have lower melting points and are softer than those held together by the stronger ionic, covalent, and metallic bonds. Van der Waals forces are a category of intermolecular forces that include London dispersion and dipole-dipole interactions. Some sources also consider hydrogen bonding to be a van der Waals force, while the ion-ion interaction is considered as non-van der Waals forces but intermolecular forces. Okay, so let's identify the first intermolecular forces. It is what we call an ion-ion interaction. It is considered as non-van der Waals forces but included in the IMF. It exists between oppositely charged ions. It occurs between ionic compounds. This is the strongest intermolecular force. Most ion-ion interactions are compounds which have high melting points and boiling points. Example of an atom or group of atoms bearing an electrical charge such as sodium and chlorine in table salt. The next one is the ion-dipole interaction. Ion-dipole interaction is an electrostatic attraction between an ion and polar molecules. The strength of the ion-dipole forces increases as the charge of the ion increases. For example, the sodium-ion-water cluster interaction. An ion dipole force consists of an ion and a polar molecule aligning so that the positive and negative charges are next to one another, allowing for maximum attraction. Ion dipole forces are generated between polar water molecules and a sodium ion. The oxygen atom in the water molecule has a slight negative charge and is attracted to the positive sodium ion. The ion-dipole interaction is a type of intermolecular force that occurs between ionic and a polar compound. An example is a sodium and a chlorine ions that dissolves in water, or we call it as a salt water solution. There are two attractive forces in ion dipole. First, between an ion and the partial positive end of a polar molecule. An example of this is a slightly positive hydrogen that is attracted to chlorine and ions. And number two, it is between a cation and the partial negative end of a polar molecule. An example of this is a slightly negative oxygen that are attracted to sodium cations. The second intermolecular force is a dipole-dipole interactions. Polar covalent molecules are sometimes described as dipoles, meaning the molecules has two poles. One end pole of the molecule has a partial positive charge, while the other end has a partial negative charge. The molecules will orientate themselves so that the opposite charges attract principle operates effectively. Individual hydrochloric acid is a polar molecule with a partial positive charge on the hydrogen and a partial negative charge on the chlorine. A network of partial positive and negative charges attract molecules to each other. The dipole-dipole interactions are intermolecular attractions that result from two permanent dipole interacting. Example of a dipole-dipole can be seen in a hydrogen chloride. The relatively positive end of a polar molecule will attract the relatively negative end of another hydrochloride molecule. The interaction between the two dipoles is an attraction rather than full bond because no electrons are shared between the two molecules. The dipole-dipole interactions occur when the partial charges formed within one molecule that are attracted to an opposite charge in a nearby molecule. The dipole-dipole interaction, based on the diagram, the dipole-dipole interaction substances with a high dipole moment as it increases, the boiling point also increases. And while as the boiling point increases, the intermolecular forces or IMF also increases. Therefore, the relationship of dipole moment, boiling point, and intermolecular forces were all directly proportional. Next, the third one, intermolecular force, is what we call hydrogen bonding. It is a special kind of dipole-dipole interaction that occurs specifically between a hydrogen atom bonded to either an oxygen, nitrogen, or fluorine atom. The partially positive end of hydrogen is attracted to the partially negative end of the oxygen, nitrogen, or fluorine of another molecule. Hydrogen bonding is a relatively strong force of attraction between molecules, and considerable energy is required to break hydrogen bonds. This explains the exceptionally high boiling points and melting points of compounds like water and hydrogen fluoride. The hydrogen bonds are strong intermolecular forces created when a hydrogen atom bonded to an electronegative atom approaches a nearby electronegative atom. Greater electronegativity of the hydrogen bond acceptor will lead to an increase in hydrogen bond strength. The hydrogen bond is one of the strongest intermolecular attractions but weaker than a covalent bond or ionic bond. What is the importance of hydrogen bonding? Hydrogen bonds are responsible for holding together DNA, a self-replicating material which is present in nearly all living organisms as the main constituent of chromosomes. It is the carrier of genetic information. Hydrogen bonding is important in many chemical processes. Hydrogen bonds hold complementary strands of DNA together, and they are responsible for determining the three-dimensional structure of folded proteins, including enzymes and antibodies. The two complementary strands of DNA are held together by hydrogen bonds between two complementary nucleotides, adenine and thymine, cytosine, and guanine. The second importance of hydrogen bonding is what we call the surface tension. The polar nature of the molecule water facilitates the hydrogen bond. Example is surface tension. Another name for attractive forces of molecules to each other is adhesion. In the case of water, this is caused by hydrogen bonding. When many water molecules form hydrogen bonds with other water molecules, they form a lattice of water molecules, which is strong and flexible. This creates a high surface tension. As a result, these molecules at the surface tension to be pulled into the bulk of the liquid and thus minimizes the surface area of a liquid. And the last one is what we call the dispersion or London forces. It is present between all the molecules. They are result of electron movement within the molecule, producing a temporary induced dipole with neighboring molecules. In other words, electrons move around with the molecules. So there will be temporary partial positive and partial negative charges produced. London dispersion interactions occur between these partial changes in different molecules. When two nonpolar molecules approach each other, attractive and repulsive forces between their electrons and nuclei will lead to distortion in these electron clouds, which mean they are induced by neighboring molecules, and this leads to the interaction. It is also considered as the weakest intermolecular forces. The dispersion or London forces are weak intermolecular forces and are considered van der Waals forces. Temporary dipoles can occur in non-polar molecules when the electrons are constantly orbit the nucleus, occupy a similar location by chance. Temporary dipoles can induce a dipole in neighboring molecules, initiating an attraction called a London dispersion force. So what happens during phase change? A phase change is a physical process in which a substance goes from one phase to another. Usually, the change occurs when adding or removing heat at a particular temperature, known as the melting point or the boiling point of the substance. Removing heat from a substance changes a gas to a liquid or a liquid to a solid. A phase change is occurring. The liquid water is changing to gaseous water or steam. On a molecular level, the intermolecular forces between the water molecules are decreasing when considering phase changes. The closer molecules are to one another, the stronger the intermolecular forces. Based on the table, it simply suggests that the strength of attraction is directly proportional to the effect on boiling and melting points, while the strength of attraction is inversely proportional to the effect on freezing point. Why does some insects can walk on the surface of the water? This lizard doesn't walk on water. It actually runs, thanks to special fringes on its toes. A basilisk lizard can escape a predator by running on the surface of the water, earning it the nickname Jesus Christ lizard. What intermolecular forces does it exhibit? The answer is surface tension and hydrogen bonding. Let us watch this experiment. How does it happen? This is a phenomenon wherein a liquid can rise on a narrow tube, and this is what we call capillary action. It involves adhesion. It is an interaction between different materials touching each other, and cohesion. It is an interaction between same materials. The intermolecular forces between the surface of the tube and the liquid allows the liquid to rise provided that the intermolecular forces between the surface and the liquid is stronger than the cohesive forces within the molecule. The next one is why does water can easily flows and fills up the glass faster than the honey? The answer is simply because of what we call viscosity. It is the resistance of a liquid to flow. The more viscous a liquid is, the thicker its consistency. Because a liquid can flow only if the molecules can move past one another with minimal resistance. Strong intermolecular attractive forces make it more difficult for molecules to move with respect to one another. In general, stronger intermolecular forces leads to higher viscosity. Let us summarize what we've learned all about intermolecular forces. Once the intermolecular molecules or ions are involved, are polar molecules and ions both present? If the answer is no, that IMF is what we call ionic bonding. While when both molecules and ions are both present, that IMF is what we call ion dipole forces. While when the molecules are not involved, that is what we call a London forces only. While our hydrogen atoms bonded to nitrogen, oxygen, or fluorine atoms? If the answer is no, that IMF is what we call dipole-dipole forces. But if the hydrogen atoms bonded to nitrogen and oxygen or fluorine atoms, that IMF is what we call hydrogen bonding. So all the London forces, dipole-dipole forces, hydrogen bonding are what we call van der Waals forces. Okay, so it's quiz time. Let's check how well you remember from our today's lesson about the intermolecular forces. Again, you can answer in our comment box. Okay, let's see the first question. Which of the following is an attractive force that happens between polar molecules? Is it A, ion-ion interaction, B, dipole-dipole interaction, C, hydrogen bonding, or letter D, London or dispersion? Okay, let's see. The answer is dipole-dipole interaction. Okay, next question. Which of the following usually occurs in polar molecules containing hydrogen and any one of the highly electronegative elements, in particular, fluorine, oxygen, and nitrogen? Is it A, ion-ion interaction, B, dipole-dipole interaction, C, hydrogen bonding, or letter D, London or dispersion? Okay, so if your answer is hydrogen bonding, you got it right. Okay, so let's see the third question. Which of the following attractive force that is present in non-polar molecules? Is it A, ion-ion interaction, B, dipole-dipole interaction, C, hydrogen bonding, or letter D, London or dispersion? Again, write your answer in our comment box. If your answer is London dispersion, that is the correct answer. Okay, let's see the fourth one. Which of the following attractive force occurs between ionic compounds which have high melting point and boiling points? Is it A, ion-ion interaction, B, dipole-dipole interaction, C, hydrogen bonding, or D, London or dispersion? Okay, write down your answer. Okay, if your answer is ion-ion interaction, that is the right answer. For the last question, water striders are small insects that are adapted for life on top of still water, using surface tension to their advantage so they can walk on water. What IMF does it exhibit? Is it A, ion-dipole interaction, B, dipole-dipole interaction, C, hydrogen bonding, or D, London or dispersion? Okay, write down your answer in the comment box. If the answer is hydrogen bonding, you got it right. This has been your physical science teacher. I'm Miss Lorena Neral saying stay safe and be healthy and goodbye.